Hi guys. So 5.5, dividing fractions. I'm doing this note sheet a little bit differently. I've already written a lot of the problems and I'm just going to kind of use the shade and talk about them as I go. I don't know if I like this or not, but we'll figure it out. So we've done adding and subtracting of fractions with like denominators and unlike denominators. We needed a common denominator. Last couple of classes, we've been working on multiplying fractions where we canceled before we multiplied. No common denominators needed. So the last operation that we need to take care of is dividing by a fraction. So one vocab word here is reciprocal. If you have two non-zero numbers whose product, when you multiply them together, is 1, you have reciprocal. So I gave you a couple examples up here. Let me move the recording. Reciprocals have the exact same sign, and it's just the numerator and denominator are flipped. So obviously, if you multiplied them, if you put a single fraction bar, your numerators would cancel, your numerator and denominator would cancel, and your numerator and denominator would cancel, and you'd be left with the ghostly 1. In this case, a positive 1, in this case, a positive 1, and in this case, a positive 1 as well. We're going to use the idea of a reciprocal to state what you do when you divide by a fraction. When you divide by a fraction, you make it a multiplication problem by flipping the denominator to its reciprocal and then multiplying the numerator by that. And now you're back to a multiplication problem, which is just like what we did in 5.4. So basically, let's just do some examples. I think this will help you, and you'll have these to work your homework with. All right, the first one. 2 over 5 divided by 15 over 16. We are going to make this a multiplication problem. We're going to leave the 2 over 5 just like it is. We're going to change the division sign to a multiplication sign, and we are going to multiply by the reciprocal of 15 over 6, which looks just like this. 2/5 times 6 over 15. Once you do this, it becomes very easy. This looks just like, I'm going to go get my pen here. I can't help but write. You know how I am. This guy right here looks exactly like every problem that we did in 5.4. You're going to use a single fraction bar. You're going to write 2, and then 6 is 3 times 2. You're going to write 5 and stretch out 15. 3 times 5. Your 3's cancel nicely, and you end up with 4 over 25 as your final answer. Number 2 I've done for you. Again, you make this guy right here a multiplication sign. But in order to do that, you have to use the reciprocal of the denominator. Leave the numerator, the 15 over 16, leave it alone. Make your division, multiplication, and flip your denominator. Now, single fraction bar, split up your numbers, cancel, 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 and 9 over 4 is our number. Let's move on. Here's 1. This is like 4 over 1. So you're going to take the negative 8 over 15, make the division, multiplication, multiply by the reciprocal, which is, there it is, 1 over 4. Again, I'm going to do a single fraction bar. I'm going to make my sign negative and circle it. I'm going to make the 8, that's a 4, 4 times 2. I'm going to leave 15 alone. I could write him as 3 times 5, but why? There's nothing to cancel him with. A 4 in the denominator, the 4's cancel, and you've got your answer. Negative 2 over 15. Move this guy over here. So now we have a mixed number. We need to make him an improper fraction. 1 and 1/2 is 3 over 2, and your negative sign comes with him. So now we're going to make it a multiplication problem. I'm going to leave my numerator. I'm going to leave my negative signs, and I'm just going to invert 3 over 2 and make it 2 over 3. Now I'm ready to talk about my signs. I'm ready for my single fraction bar. A negative times a negative is a positive. 12 is 4 times 3. Here's the 2, comes down by himself. 21, 7 times 3, and there's the 3 from the second fraction. These 3's cancel, nothing else looks like it's going anywhere, and I've got 8 over 21. I hope you guys are thinking this is fairly easy. If you've got the multiplication of fractions down pat, this should not be very difficult. Number 5, I've added a 2 operation problem here. Because we have the grouping symbol, we are going to do the 4 over 5 plus 2 over 3 first. That's the PEMDAS part of this. 5 and 3, I need a common denominator. Off the top of your head, you might see that it's 15. I change 4 over 15 to 12 over 15, reminding yourselves that 5 times 3 is 15, so 4 times 3 is 12. 2 over 3 becomes 10 over 15. I can do this addition piece and get 22 over 15. And finally, I'm ready to go back and tackle the division. I'm going to make the division multiplication. I'm going to invert the 22 over 15 and make it 15 over 22. And finally, I'm ready for the single fraction bar. Make your 8, 4 times 2, your 15, 3 times 5. Here's the 3, and we split the 22 up into 11 times 2. Now I have several things that'll cancel, and I put it back together again. Number 6, I've added some variables. Yay, aren't we excited? We're going to make it a multiplication problem. I'm going to invert 18 over 7 and do 7 over 18. Single fraction bar. They're both positive, so I don't have to worry about the sign. If you want to write it down, you can. I'm going to move my 7 to the front. Numbers, constants come to the front, variables to the rear of the bus. 3 times 7, 14 on the bottom, 7 times 2, and 18, 3 times 6. Lots of stuff cancels. I love it. All that's left is the x squared in the numerator and 6 times 2, 12 in the denominator. All right, we've got a couple problems where they're giving you some values for the variables, and they're giving you an expression to plug your numbers in for. You have to be real careful when you're plugging these numbers in. That's why I've spread it out. I've got addition and subtraction, and I've got multiplication and division. So you have to be careful and see what you have. I don't even know why I wrote that. Maybe it'll come to me later. Okay, so let's look at our problem in number 7. I've got division and I've got multiplication. I don't see any grouping symbols. I'm going to go back and go to the beginning of the problem, and I'm going to do it from the beginning to the end, because that's what we do when we have multiplication and division. So I'm plugged in for my variables. You can see I've spread them out. I've put parentheses around them. I'm going to do this division piece first. I'm going to make 6 3/4, 27 over 4. 4 times 6 plus 3. I'm leaving the division sign until I make all of these mixed numbers improper fractions. That's the only thing I'm going to do in this step. Then I'll worry about the rest of it. All right, I've done that. I come down. In the next step, I'm going to change this division to multiplication. I'm going to make 21 over 8, 8 over 21, and I've written my sign down of this product. This is a positive times a negative is a negative. There's my sign. There's the 24 times 7 and the 8 times 21, and I'm multiplying. Remember, this 3 over 10 is on the back end waiting for his turn to be multiplied. Now I've got 3 fractions that are multiplied together. I can do them all together. I've got 3 things multiplied, 1 single fraction bar. I'm going to determine the sign of my product. I've got a negative times a positive times a positive. That's a negative. I'm going to take 27 and I'm going to make him 9 times 3, because that's about all you can do with 27. I've got 8 and I've got a 4 on the bottom. Those are going to cancel. So I'm going to make 8. Instead of going 2 times 2 times 2, I'm going to do 4 times 2. And there's the 3. In the denominator, I've got my 4. I've got 21, which is 3 times 7. And I've got my 10, which is 5 times 2. Now I start canceling. Notice I've spread these guys out so that I can cancel neatly and see what I've got. I am working how? Oh, yes, down the page. Please, 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 down the page. The 4's cancel, one of the pairs of 3's cancel, the 2's cancel, and I have to put it back together again. My sign is negative, negative 27 over 35. And we're done with that problem. Long as it was, you can just do it step by step by step. Let's move on. Got a couple more that I've worked for you. Notice that this is division, so I'm going to make it multiplication by inverting the fraction. There is no addition or subtraction, so I'm a happy camper here. I don't have to do common denominators. All I have to do is my single fraction bar, move the numbers to the front and the variables to the back of the bus. 10 is 5 times 2. 26 is 13 times 2. I'm kind of liking this because I see a 13 down here. That's looking good. And I make 15 5 times 3. Cancel what you can. Put it back together. It's all positive because everything was positive. Here's your answer. One more in this section. 4 divided by 2 over 3. This is like 4 over the ghostly 1. If you want to make him a fraction and it helps you see it a little clearer, then do that. Make it a multiplication problem. 4 over 1 times the reciprocal, which is 3 over 2. Single fraction bar, cancel, cancel. 6 is your answer. Okay, a couple more, and then we're going to stop. In 10 and 11, it asks you to change the decimals to fractions, then do the division. This is actually an easier way to do this, especially if you don't have a calculator. I'm going to rewrite 0.15 as 1500ths. Just say its name. 0.15 is 1500ths. 0.2 is 2/10. Now you can go back up and do what we've done on this entire note sheet. You've got division of 2 fractions. Make it a multiplication problem. Invert the second fraction. So you have a single fraction bar. You're multiplying 15 times 10 and 100 times 2. 15. I could write him as 3 times 5, but why bother? There's nothing to cancel with. So I'm going to leave him alone. I'm also going to leave the 10 as 10, because when I look in the denominator with my eagle eye, I see that 100 can be written as 10 times 10. So that's a far better way to cancel than to divide 10 all the way down. So the 10s cancel, put it back together again. You have 15 over 20. Oh dear me, I can still take something else out. I must not have seen it back up here. But no problem. I can write 15 as 5 times 3 and 20 is 5 times 4. And I do get my simplified answer finally of 3 over 4. Sometimes you don't see the biggest thing to take out. You always have to look at your final answer and say, is this simplified? Are these guys relatively prime? 15 and 10 are not. Okay, let's work 11. I'm going to change 0.6 into 6/10, and now I'm ready to roll. I'm ready to change division into multiplication. I'm ready to do a single fraction bar. I've inverted 6 over 10 to 10 over 6. I've moved my variables to the back of the bus. 3 is here, and 10 is 5 times 2. Here's my 5, and here's my 3.2. All of the numbers cancel, and I end up with x squared over y, or x squared y over 1, or just x squared y. Does that look good? All right, you guys finish up page number 4 on your own. Bring it completed to class, and I will see you then. Thanks for listening.